At 1,347 hours in the occupied region of Zaparicia, a formation of 12 Ukrainian drones raced toward a Russian ammunition train, their speed holding steady at 97 kilometers per hour. Unbeknownst to their controllers, Russian artillery had already pinpointed their launch site. The first 152 mm shell struck the earth 800 meters away, its concussion strong enough to dislodge dust from the bunker's ceiling. The Russians had identified them the instant their 48 brushless motors whirred to life in unison. That surge of electromagnetic energy illuminated enemy sensors within a 10-kilometer radius, as conspicuous as a beacon in the night. The drone operators were faced with a critical decision: abort the mission and preserve their own lives, or press on while under direct artillery fire. They estimated 12 minutes until the drones reached the train. The Russian gunners would likely need only 3 to 0 in on their coordinates. They chose to continue. A Russian BTR armored vehicle sighted the drone swarm and unleashed a torrent of fire. Tracer rounds cut bright paths through the morning sky. In response, the formation fractured with instantaneous precision. 4 drones climbing high, 4 dropping to a low altitude, and 4 holding a central course. Machine gunfire sliced through the space they had just vacated. What the Russian forces could not perceive was that each drone was tethered by a fiber optic cable, a thread finer than a fishing line. While Russian jamming systems flooded every radio frequency with 10 kilowatts of disruptive noise, these slender cables transmitted data at the speed of light, rendering them utterly immune. The $10 million electronic warfare vehicle stationed nearby was effectively neutralized, as useful as a paperweight. As the drones proceeded toward their target, Russian artillery rounds began hammering the operator's last known position. However, the Ukrainian team had anticipated this. They had dispersed across 3 separate bunkers, each spaced 500 meters apart. This specific distance was crucial. A 152 mm shell has a lethal radius of approximately 300 meters. With 500 meters between them, even a direct hit on one bunker would leave the others unscathed. The Russians might, with extraordinary luck, destroy 1 or 2, but never all 3. A minimum of 8 drones would always remain to fulfill the mission. The second artillery shell landed closer, 600 meters out. Through the camera of the lead drone, the operator now had a clear view of the target, a train identified by the black diesel smoke pouring from its engine. It was entering a pre-selected stretch of track, a straight 2-kilometer segment through open ground, too distant from defensive positions for protection to be effective. The Ukrainians had analyzed this route for weeks. The attack window would last precisely 97 seconds. The third shell impact, 450 meters away, altered the situation dramatically. Shrapnel from the blast, traveling at 500 meters per second, found its mark, severing the fragile fiber optic cables linked to drones 2, 5, and 8. Instantly, these 3 drones switched to their backup battery power and radio control, suddenly exposing them to the enemy's jamming systems. The remaining 9, their fiber optic tethers still intact, continued their flawless date to transmission via pulses of light moving through glass at 200 kilometers per second. The team in the first bunker gave the order to continue the mission while relocating. As they gathered their gear to move to a secondary position 700 meters east, a 4th artillery round detonated just meters from their former location. They were already gone, sprinting through a connecting tunnel. The Russian gunners would now have to require the target, a process that would consume precious time they could not afford. While 3 drones were now susceptible, the 9 still linked by fiber were entirely unaffected by the electronic assault. Radio signals, which travel through the air, are vulnerable to noise sent across their frequencies. In contrast, fiber optics use light confined within glass strands. Attempting to jam a light signal with radio waves is as futile as trying to extinguish a flashlight by screaming at it. The underlying physics do not allow for interaction. The 3 drones operating on radio control were about to be tested. The R3 130ZH digital electronic warfare system at the rail junction detected the swarm at 7 kilometers and activated, flooding the spectrum from 100 MHz to 2 GHz with 10 kilowatts of power. Enough to overwhelm every commercial drone channel, GPS signal, and radio link within a 30-kilometer radius. The 3 radio-controlled drones immediately went dark, their screens dissolving into static. The other 9 pressed on, unaffected. Inside the Zhitl's command cabin, the operator watched his display, perplexed. He had created an impenetrable 30-kilometer electromagnetic bubble, yet 9 signals continued to advance, their data streams perfectly clear. He increased power, saturating every frequency with jamming noise, creating a cacophony equivalent to 1,000 speakers blaring at once. It made no difference. This highlighted a fundamental flaw of electronic warfare, its indiscriminate nature. The Zhitl's powerful jamming field did not distinguish between Ukrainian and Russian systems. The crew of a BTR-82A at a nearby checkpoint, seeing the drones on thermal imaging, tried to radio a warning to a Pantsir air defense unit. They heard only static. The Russians had deafened themselves in their attempt to deafen the enemy. The 9 tethered drones flew on, undeterred. The multi-million-dollar electronic warfare system was powerless against a connection that was, in essence, a very long and sophisticated piece of string. Aboard the train, the engineer, who had been briefed on the drone threat, pushed the throttles forward. The heavy convoy accelerated from 42 to 48, then 52, finally reaching its maximum of 56 km/h. But this acceleration introduced a new complication. Every kilometer per hour of increased speed shifted the calculated intercept point 17 meters further down the track. The Ukrainian operators were forced to continuously recalculate the drone's paths, each course correction draining precious battery reserves. The BTR crew at checkpoint 9 had a mere 8 seconds to engage as the swarm crossed perpendicular to their position. The gunner swung his turret, calculating the lead angle for targets moving at 27 meters per second. He needed to aim 15 meters ahead of them. He opened up with his PKT machine gun, but by the time he adjusted his fire, the drones had already passed behind a tree line. Engaging 9 plate-sized targets moving at highway speeds in an 8-second window was a geometrically impossible task. In simulators, targets moved predictably. These drones jerked erratically every 2 seconds, their movements as random as a hummingbird's. The gunner could even see their fiber optic trails glinting in the sun like strands of spider silk. He was trying to shoot at shadows. The BTR commander slammed his fist in frustration, unable to even report the failure because his own radios were jammed. The 9 remaining drones continued their approach, now 2 kilometers from the intercept point. The Pantsir S-1 air defense system at the junction detected them on thermal imaging, its advanced radar having filtered out their small signatures as ground clutter. The operator switched to electro-optical mode, manually tracking the incoming swarm through a powerful telescopic sight. The system was about to demonstrate that a single lucky shot could change the dynamic. The Pantsir's Twin 2 A38M Auto cannons opened fire at 200 meters. The gunner wasn't aiming to hit individual drones, a task akin to shooting mosquitoes with a rifle. Instead, he programmed his 30 shells for airburst, each round fracturing into a 4-meter sphere of 400 steel fragments. At 5,000 rounds per minute, he was building a wall of shrapnel. Drone 6 disappeared in a fireball at 900 meters. 3 seconds later, Drone 11 met the same fate. The 7 surviving drones instantly scattered, 3 climbing to 200 meters, 3 diving to grass, top level, and 1 maintaining altitude while jinking laterally. This forced the Pantsir gunner into a critical dilemma. His computer recommended engaging the high-altitude group, as they were easier to track against the sky. But his training dictated engaging the closest threats first. With 2 seconds to decide, he chose the high group, unknowingly repeating a tactical error that had doomed another train weeks prior. He elevated his barrels, committing his firepower upward. This was a classic air defense error. The closest threats have the least time to react. While the Pantsir's guns chased the climbing drones, the low-altitude group raced toward the train, unopposed. The gunner realized his mistake, but could not traverse his turret fast enough to require them. They were already outside his optimal engagement arc. A new threat emerged as a platoon of Russian soldiers at Observation Post 7 added their rifle fire. 40 AK fired in synchronized bursts, but the shot was nearly impossible. At 200 meters, each drone spent a mere 0.74 seconds in a soldier's sights. Factoring in a 0.25-second human reaction time and another 0.5 seconds to aim, the drone was long gone before a trigger could be pulled. Simultaneously, 4 specialized drones that had been loitering at 500 meters dove toward the railroad tracks 800 meters behind the train. They released their payloads as 1 thermite charges. Thermite is not a high explosive. It is a pyrotechnic composition of aluminum powder and iron oxide that burns at 500 degrees Celsius. Railroad steel melts at 370 degrees. The thermite ate through the rails like a blowtorch through butter, turning 4 sections of track into pools of molten metal in seconds. Back at the Pantsir, the gunner's barrels glowed cherry red from the sustained fire. Modern autocannons can only fire at maximum rate for about 45 seconds before heat warps the barrels, causing rounds to tumble and accuracy to vanish. He was forced to cease fire to cool the system, creating a critical 12-second window of opportunity. The 7 remaining drones surged forward. Amber battery warnings flashed on the operator's screens. Fighting headwinds and making constant corrections had drained power faster than anticipated. Drone 3 showed 18%, Drone 7 showed 21%. They needed 30 more seconds of flight, but had only 20 left in their batteries. Smoke from the thermite, induced grass fires drifted across the battlefield. While thermal imagers can see through darkness and fog, they cannot penetrate smoke. Carbon particles absorb infrared radiation completely. For several crucial seconds, every Russian defensive position was blinded. The drones emerged from the smoke 400 meters from their target. Their cameras now revealed fine details on the train cars, unit markings, patches of rust, and on Wagon 22. A stark white stencil warning Class 1. 1 explosive. The fiber optic cables were nearing their maximum length. At exactly 12.00 meters, they would automatically release to prevent tangling. The countdown began 10, 5, 3, 2. The first cable released 13 meters short using a mechanism adapted from fishing reels. Drone 1 switched to battery power, its charge at a precarious 8%. The other cables released in sequence over the next 3 seconds. The drones were now free, vulnerable to jamming, but also too close to be stopped. They were 530 meters from impact and closing at 27 m/s. The train engineer saw them through his windshield, 7 black specks swelling against the sky. He slammed the throttle past its safety stops, forcing the diesel engines to redline. This desperate action backfired. The locomotive's driving wheels lost traction on the steel rails, spinning uselessly. The coefficient of friction for steel drops from 0, 78 when static to 0, 25 when slipping. The train actually slowed by 2 km/h as the wheels polished the rails. The Pantsir attempted one last engagement, but the drones had now entered its minimum range of 500 meters, where its cannons could not depress low enough to hit them. The $20 million system, designed to engage high-flying aircraft and cruise missiles, was defeated by simple geometry. The gunner could only watch helplessly as the drones dropped below his firing arc. Russian soldiers at the final checkpoint unleashed a storm of fire from machine guns, rifles, and even RPG detonated in the air as makeshift flak. But the drones were flying directly along the center line of the tracks, using the train itself as a shield. To hit them, the soldiers would have to shoot through their own valuable cargo. The geometry of the attack protected the drones perfectly. At 100 meters from the target, Drone 3's battery died. Its motor fell silent, the props windmilling, but its momentum carried it forward. At 97 km/h, with minimal air resistance, it glided the remaining distance, a dead bird coasting on inertia alone, a final, calculated move by its operator. Through a last functioning camera, an operator watched Russian combat engineers frantically trying to decouple Wagon 22 while the train was moving. The coupling was under 4,000 tons of tension. It was a futile effort, like trying to untie a steel knot being pulled by bulldozers. Drone 9 was struck by shrapnel from a PKM, its battery damaged. It spun into a wheat field 400 meters short. 6 drones remained. The operators had planned for 60% losses. They only needed 4 hits to succeed. At 1,359 hours, the lead drone struck the coupling between the locomotive and the first wagon. Its RPG-7 warhead detonated on impact, the shaped charge producing a jet of molten copper traveling at 2,800 m/s. The massive steel coupling pin was sheared instantly. A rapid sequence of impacts followed. Drone 1 ruptured the fuel valve on Wagon 3, releasing a geyser of pressurized diesel. Another severed the brake lines on Wagon 7, locking the wheels of all subsequent wagons. A third penetrated the thin skin of Wagon 18, an ammunition car, triggering secondary explosions. The final successful hit pierced the ventilation system of Wagon 22. Inside that wagon, 12 tons of TOS-1A thermobaric rockets, already heated from damaged seals, saw their internal temperature skyrocket. It passed the auto-ignition point of 447 degrees C. The fuel-air mixture detonated with a pressure wave moving at 3,000 m/s. Wagons 20 through 24 were vaporized into plasma. The blast wave hurled wagons 25 through 47 from the tracks, flipping them end over, rend across the landscape. A mushroom cloud rose 400 meters into the air. In 4 seconds, a swarm of drones worth roughly $4,800 had destroyed $127 million worth of Russian military assets and severed the sole rail line supplying 3 mechanized divisions poised for planned assault. The mission was over.